curve y equals to x squared minus ax has a stationary point at negative 3b. Stationary points means that the derivative is equal to 0 because that's where it turns, right? It balances out. For example, like this is called the stationary point, where the gradient of tangent at that point is equal to 0. So how do we figure this out? You take up the equations given to you, which is y equals to x squared minus a over x. I'd like to write it into a times x to the power of negative 1, so I can differentiate it better, easier. Okay, then what I do is I'd find dy over dx. In our situation here, then I'll be having 2x plus ax to the power of negative 2. Remember, when you differentiate, we are multiplying with the power, right? We are multiplying with the power in the front, and then the power will be subtracted by 1, will be reduced by 1. So you have that 2x, and then the power times with negative a, I have positive a, x to the power of negative 2. Now from here, I can equate that at point, okay, at point negative 3b, my dy dx would be equal to 0. Therefore, dy dx at that point exactly, which means my x is negative 3, my y is b, right? My x is negative 3, and I'll be having 2 times negative 3 plus a times negative 3 to the power of negative 2. Or I can rewrite this as to be, this is negative 6 plus a over negative 3 squared. Okay, negative 3 squared is just 9. So I'll be having 0 is negative 6 plus a over 9. You have to be careful with a and 9, they look much alike. Right, so I have here 6 is equals to a over 9. Therefore my a is equal to 6 times 9 equals to 54. I got my a. How about my b? Right, once you know that your a is 54, means that you can rewrite your equation with the value of a that you have found, which is y equals to x squared minus 54 over x. Finding the value of b, you just need to substitute the coordinate given to you, which is b is happening when your x is negative 3 squared minus 54 over negative 3. Right, calculating this, you can simply get 9 plus 18, that is 27. Okay, done.